let's look at the problem from 8.1. We'll work through this one and it'll help you get an idea of where all the numbers come from. Okay, so the idea in this chapter, not just this section, but in this chapter, is that we want to take some sample data and use it to get an estimate for the population value. Okay, so in order to be more accurate about that, we will use a range of values as our estimate. We'll say that the population value falls in a range of values. And how confident we are that the value is in there, as I called our confidence level, we'll make a confidence interval. So the first thing we need for a confidence interval is we need a point estimate. We need some number to start with. Okay, so our point estimate in this section is going to be a sample mean. Okay, so here it says for a sample of 1,576 third graders, the mean words per minute read was 31.2. Okay, so that is going to be our sample mean. So that's what we're gonna start with, x bar, 31.2. And then we want to build our confidence interval around that initial starting point, around that sample mean. Okay, and we're going to use our confidence level and our information we have from our data to do that. So to figure out how far above and below the confidence interval we need to go, we need to come up with a margin of error. And our formula for a margin of error is we have this, what we call a critical z-value, is z sub the Greek letter alpha divided by 2, z sub alpha over 2. Okay, comes into play here. Then we're going to multiply by the population standard deviation, sigma, divided by the square root of our sample size, n. Okay. And this number that we calculate will tell us how far above the sample mean and how far below the sample mean we need to go for our estimate. Okay. So to come up with this number, this critical z-value, and we're going to look at our confidence level. So it says we want to be 99% confident. Okay, so that 99% confidence is going to tell us how to find our critical value of z. So I'm going to go over to the side and I'll take note of what our critical value of z is going to be. Okay, and to look this up, we've got an easy little chart. If you go into Hawks, okay, might be a little hard to find in here, so that's one thing I wanted to show you. You can click on tables, and we're using the z table, the standard normal table. And what we're using are called critical z values. So we'll go down to this critical table, or critical z value table. Okay. So on this problem it says we want to be 99% confident. So it gives us confidence over here, 0.99, 99%. So our z alpha over 2, our critical z, is going to be 2.575. And it says plus or minus. You don't have to worry about the negative ones right now. We're only going to use positive. So our critical z value on this problem is 2.575 based on our 99% confidence. So I'm going to write that down. And our critical z, 2.575. Alright, and then we want the other two numbers out of our formula. We want the population standard deviation and the sample size. So we look back at our problem. It says for a sample of 1,576 third graders, that is our sample size n. Okay, and then it also tells us assume a population standard deviation of 3.6. So that is sigma. Sigma will be 3.6. You really got to learn these symbols, okay? Because you'll have the formulas, but you need to know what symbols stand for what number. Okay, so when we plug into our margin of error formula, we get 2.575 times 3.6 divided by the square root. I almost forgot my square root of 1,576. Okay. And on these margins of error, you want to be really careful. You don't want to round too much, okay, too early. We don't want to really round until we get to the very end of the problem. So let's see what we get. 2.575 times 3.6 divided by the square root of 1,576. It gives us a long number, and it's a good rule of thumb to leave about 5 or 6 decimal places here. So 0.23350 8. Round up 79, so we round up to 8. So we want to leave, 5 or 6 decimal places. That way we don't introduce any rounding error. Okay, so now we're almost finished. We've got the 2 things we need to make our interval estimate, our confidence interval. We have our point estimate, our starting place, and we have our margin of error that tells us how far above and below that number we should go. So the only other thing we need to do is we need to add and subtract. Okay, so to make the confidence interval, it's going to end up looking like this. It's going to be x bar minus e, and x bar plus e. Okay. Or on Hawks, it's going to give you 2 boxes. It's going to ask for the lower endpoint and the upper endpoint. So the lower is when you subtract, the upper is when you add. So x bar is 31.2. So we're going to take 31.2 and then plus our margin of error. That tells us how much to add. So 0.233508. Okay. And then we're also going to do 31.2 minus the margin of error. So same numbers, but we're just subtracting. That will give us our lower endpoint. So for the upper endpoint, we've got 31.2 plus 0.233508. And you're going to get a bunch of digits, but on this problem it tells us to round our answer to 1 decimal place. Okay. So now we can round since we're at the end. And now we can round. So I'm getting 31.433508, but when we round, it'll be 31.4. So that will be my upper endpoint. And then when we do the lower endpoint, we subtract. So 31.2 minus 0.233508. Okay, so there I get 30.966492. And when we round to 1 decimal place, this one's a little tricky because we're rounding to 1 decimal place. The 6 is going to make that round up to a 10. And so we have to carry, so we get 31.0. The rounding's a little bit tricky on that one. The rounding's a little bit tricky. So we get our 2 answers for Hawks, or if we were writing it like an interval, we would write it like this. 31.0 is our lower estimate. 31.4 is our upper estimate. Okay. So you can do all these confidence intervals this way. The only thing that's going to change, okay, your numbers over here, your population standard deviation and your sample size are going to change. Okay, the critical Z that we look up from the table is going to change, but it depends on our confidence level up here. Okay, so it depends on whatever our confidence level is that gives us our critical Z. And then the other thing that will change is our sample mean that we start with. Okay, so the sample mean, population standard deviation, and sample size all come from the data. The critical value of Z comes from the confidence level. Then we plug into the formula to get our margin of error. And then we take our sample mean and we add and subtract the margin of error to get our upper and lower endpoint. Okay, so the numbers change, but the process will be the same. Let me know if you have any questions.